Alrighty, so in this video, we are going to identify the graphs of functions that we should be very familiar with. So the identity function, f of x equals x. This is a fancy way of just saying the f of x is letting us know this is a function. So this is y equals x. So what this means is every x is what y is. So if x is -2, y is -2. -1, -1, 0, 1, and 2. And then when we graph these points, and those are just random points that we ourselves picked, we get a straight line. Boom, 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 boom. And we are only looking at, there's more than one way to graph this straight line, and lines go on forever. But whenever x is to the first power, whenever we have x to the first power, we know we are going to graph a line. So as stated, the x values that this line exists on, which x values can I plug into this x to get out a real y, are any x's. I can plug in absolutely any x. My domain goes all the way from the left at -infinity. If x is -infinity, y is -infinity. I can do all, and then I can get off -infinity, start getting more positive. -1000, -1000, 0, 0, a million, 1 million. And I can do all that until I get up to positive infinity. And as we just saw, every x generates the same y. My range is my y values. These are the x values that I can plug in, and these are the y values that I get out. So as we can see, f of x, y equals x is always increasing. It is always increasing, and it is continuous on its entire domain. Continuous over its entire domain. Increasing means as we travel from left to right, my y values get bigger. Try to draw that as an arrowhead. From left to right, my y values will go up. So this is my squaring function right here, x squared. Whenever this is the highest term, the squaring function is going to pair every real number with its square. We are going to make a parabola, my favorite math shape, because this lets us watch satellite TV. Every satellite dish is a parabola. There's a parabola. And it changes from decreasing. So decreasing means as we read it from left to right, we are going to go down, to increasing. As we read from left to right, our graph goes up. At that point 0, 0, which is called the vertex. So here are my x values. These are my inputs, my domain. If we input a -2, -2 squared is 4, -1 squared is 1, 0 squared, 0, 1 squared, 1, 2 squared, 4. And so when we graph this, now these aren't all the points that I could do, but when we're actually making a t-chart and we are graphing these, we can only do so many. Boom. And of course, my graph should have arrows on the end because it keeps going forever. So again, the domain is asking which x values can I plug in? Well, I can plug in any x value I want. It's the x values that I can plug in and square. Which numbers can I square? Well, I can square any number I want. That's why it's -infinity to positive infinity. Well, what values of y then will we put out? So y goes from the bottom to the top. So it's easiest to show this with a horizontal line. So what we're going to do is we're going to start down here and we're going to start raising this line up. So as you can see, there's no graph, there's no graph, there's no graph as my horizontal line is going up. And it finally hit, boom, it hits right there. So what is that y value? Well, I'm glad you asked. That y value is 0. And then the line can keep going up and up and up and up and up and up and up. And it keeps going up forever. So it never stops. Now, infinity gets a parentheses because you're never allowed to be infinity. But the 0 gets a bracket because I can be 0. Plug in a 0, get out a 0. So now let's look at my increasing and decreasing part. F of x equals x squared. My square function decreases. So decreases means as I read it from left to right, we go down. And we want the interval. The interval is my x values. Well, as I'm reading my x values, boom, boom, boom. So my graph is going down, it's 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 going down. It hits right there. That is my vertex. That is the vertex of this graph. And the vertex is where it turns around. So we decrease it, we were decreasing from on the interval from negative infinity to 0. And then what happens here? When we hit the vertex, the graph starts getting bigger. It starts increasing again. As we read x from left to right, y goes up to down. And so we increase from 0 to positive infinity. And why I don't use a bracket this time is the 0 is neither included in the, we don't include it on the decreasing part or the increasing part. 0 is exactly that point in the middle. And as you noticed, we were continuous on all real numbers in my domain. No matter, I can put it in, and as I trace my graph from left to right, I never pick up my pencil. So my cubing function pairs each real number with the cube of that number. The point at 0, 0 is at which the graph changes the opening downward to opening upward is what we call our inflection point. Oops, that's our inflection point. Some people will call it the point of inflection. Either way. Either way. So when we take these values of our domain and we cube them, -2 times -2 times -2. So -2 times -2, that's +4. +4 times -2 is -8. A -1 raised to the third power is still a -1, because a negative times a negative times a negative, odd powers will give me a negative in is a negative out. 0, 1, and 8. So what that looks like is we're going to have to come off the graph a little bit. That's okay because it exists forever. We graph these points. And it makes kind of this, it never gets straight. It always, you can see it better here a little bit. It always goes to the right as it's going up. So domain, what values am I allowed to cube? What values can I raise to the third power? Well, I can raise any number I want to the third power. Well, what are the outputs if these are my inputs? Well, if I take a really large negative number and I cube it, I get out a very large negative number. Take a very positive number, cube it, and get out a very large positive number. That's what the graph is showing us. I can plug anything in, and it gives me anything out. So we can see again that x cubed, it consistently increases. It never decreases. As we read it from left to right, it's going up, 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 up. It goes up a little bit slower, and it turns a little bit, but it never goes down. It always increases, and it's continuous over its entire domain. It is, I never have to pick up my pencil to trace it. We can also do a root function, a square root specifically. This is going to pair each real number, no matter what number I put in. It's going to pair it with the principal square root. We're looking at our positive square roots. No imaginary numbers. For the function value to be a real number, the domain must be restricted to my non-negatives. And I'm going to show you how that affects my domain in a minute. Well, let's just jump right down here to the domain. What that means, if we are dealing with non-negative numbers, we cannot take the square root of negative numbers. So when I plug in for x, x is not allowed to be negative because I don't want to take the square root of a negative number because I want it to output a real value. So the smallest value that I can plug in for x is 0. And then I can plug in any positive value so it goes on forever. I can plug in 0, so that's why I use the bracket. And then let's come back for the range in 1 minute. That's what non-negatives mean. That is what my inputs are. So if I plug in 0, the square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Notice in my x values, x can be any number you choose as long as it falls within the domain. I use numbers I could take the square root of. So that gives us this graph. And then I notice I can't go out to 9. It's not there. It just gets bigger and bigger. It would be a graph that looks like that. So again, we can see that the square root f of x is increasing on the interval. Where does it start? Well, it starts at 0, and then it starts at 0, and then it keeps going on forever and ever and ever. Oops, bracket, because this time I can be 0. 0 works, never being continuous, and it is continuous on the entire domain. That's an E. Boom. Easy peasy. Can always make a t-chart, always graph them in your calculator. Well, what if we take the cube root? The cube root function, f of x equals the cube root of x, pairs every real number with its cube root. That's easy enough. So if we take the cube root of -8, that's going to be -2. Cube root of -1, -1. Cube root of 0, 0, 1, +2. So if we go out -8 to -2, -1 to -1, 0, 0, 1, 1, 8, 2, you'll notice we get something that kind of looks like my cube function, but it's laying on its side. And notice here it says each real number. So again, we're going back to a domain of -infinity to infinity because we can take the cube root of any number. And when I take a cube root of a negative number, it kicks out real numbers. You know what? Did I go over range? I did not go over range on this one. Gosh darn it. No one stopped me. So remember, range is where the y values exist. So if you draw a horizontal line, at what y value does my graph start? Well, my graph starts right there at 0. And then the graph keeps going up and up and up and up and up. And it keeps going up because that arrow means go to the right and go up forever. And the range goes on forever. So we can be 0 and we go on forever. Boom. So f of x, the cube root of x is increasing and is continuous over its entire domain. Alright, so when we get into class, we will do the absolute values. So try to do that before you come into class. And if you've got any questions, I'll definitely be glad to answer them. Hey, and I'll see everybody when I see you.